next question, number 44. In the given network, V1 equals 100 angle 0, V2 equals 100 angle minus 120 and V3 equals 100 angle plus 120. The phasor current I in ampere is, we have our four options. Now the first step is to make sure that your values of voltages are in rectangular form, because when they are in polar form it is a little difficult in order to solve it. So the best way is to first convert them into rectangular form and then solve. So here's the first step. We'll write down V1. We have 100 angle 0 given to us. Now in rectangular form it is 100 plus 0 J. V2 similarly 100 angle minus 120 degrees. Now you can either do it manually or you can use your calculator, the best being the calculator, since it does it for you, does all the work for you. It's easier that way. So V2 is 100 angle minus 120. Converting it into rectangular form, we get minus 50 minus 86.60 J. And then V3, 100 angle 120 is minus 50 plus 86.60 J. So these are the values of our voltage sources here in rectangular form. Now since we are supposed to find out the value of I here, the direction is given to us as this way. So we'll assume that the current here and here, we'll call this I2 and we'll call this I1. So I would equal to I1 plus I2. If we are to use KCL, the incoming currents, the sum of the incoming currents equals to the sum of the outgoing currents. So in this case, let's first find out the individual values of I1 and I2 and then add them up, which will give us the value of I. Okay? We'll begin by writing down the value of I1. So I1 from the figure here, I1 can be found as V3 minus V1 divided by the capacitance over there written as minus J1. So that's the reactance, right? We will have to write that down. So I1 is V3 minus V1 divided by minus Ji. So let's put down the values of V3 and V1 here. We found V3 to be minus 50 plus 86.60 J, that's V3, minus, what's V1? 100 plus 0 J, divided by minus J1. So this now gives us minus 150 plus 86.60 J divided by minus J. Now in order to solve this part, we have to convert it into polar form again. Now the polar form of minus 50 plus 86.6 J is 173.20 angle 150 divided by minus J is 1 angle minus 90. Now solving the angles alone, that will give us 173.20 angle 150 plus 90, which is angle 240. Now angle 240 can also be written as minus 120. So 173.20 angle minus 120. So this is our value for I1. Now let's do the same thing in finding out the value for I2. Now I2 from our figure here is V3 minus V2 divided by J1. So that's V3 minus V1 V2, sorry, that's V3 minus V2 divided by J. Let's substitute the values. We should have minus 50 plus 86.60 J, that's V3, minus V2, which is minus 50 minus 86.60 J, whole divided by J1. Now let's solve this. Let's see here, 50 cancels out and that leaves us with 173.2 J divided by 1 J. Now we can cancel out the J's and that will leave us with 173.2. So here we have our value of I1 as 173.20 angle 120 and I2 is 173.2. Now all that's left to be done is to add the values of I1 and I2 to get the value of I. So we'll note that down here. I equals I1 plus I2. So let's add the values here. 173.2 plus 173.2 angle minus 120. Now we cannot add it this way. What do? We convert it into rectangular form. Yeah, a whole lot of conversions, but it is necessary. So here we have 173.2. Since it's real, we leave it as it is. This we need to convert. So when we do convert it, we get minus 86.60 minus 150 J. So this is the rectangular form for the polar coordinates here. Now let's solve. 173.2 minus 86.60 gives us 86.60 minus 150 J. So this is the rectangular form for the current I. And finally, we convert it into polar because our options are given in polar form. The phasor current I is in polar form. So when you convert it, you should get a value of 173.2 angle 300. Now angle 300 is also angle minus 60. So this is our final value for I. 173.2 angle minus 60. And this matches option A. So option A is the right answer. This is the entire solution and I hope it has helped.